Electric capacitance of a conductor. To understand about the electric capacitance of a conductor, let me take you an example of a water added to a tank. As you fill water into a tank, then the level of water will rise. Okay, so similarly, when a charge is given to a conductor, then the potential of the conductor will increase. Alright, so it is just like water added to a tank increase its level. So similarly, a charge given to a conductor will increase its potential. So if a charge, let's say a charge Q, right, is added to a conductor, and the potential at any instant, let's say it is V, then we can say that this Q, it is directly proportional to V. That means the amount of water added to the tank, right, is directly proportional to the level of the water in a tank. So therefore, when a charge Q is added, right, let's say, okay, when a charge Q is added to a conductor, and let's say the potential at that instant is V, then Q is directly proportional to V, or Q is equals to CV, where C here is a constant of proportionality, and it is called the capacitance of a conductor. So therefore, if you rearrange, or if you find out C from here, you will get C is equals to Q upon V. Okay, so this is the equations of the capacitance of a conductor. Now let us define the electric capacitance from this equation. Now if I substitute V is equals to 1 unit, let's say it is equals to 1 volt. If V is 1, then C is equals to Q. So therefore, we define the electric capacitance of a conductor as the charge which is required to increase the potential of a conductor by 1 unit. Okay, so this is about the definition. Okay, now what are the factors which affects the capacitance? The factors that affects the capacitance of a conductor are as follows. Number 1, the capacitance of a conductor depends on the size and the shape of a conductor. Number 2, the capacitance depends on the nature of the medium, or in other words, we can say the capacitance depends upon the permittivity. Number 3, the capacitance of a conductor, it also depends upon the presence of other conductor in its neighborhood. So these are the factors which are actually affects the capacitance of a conductor. Now the SI unit of capacitance is farad, and this farad, it is equivalent to coulomb per volt, because from this equation C is equals to Q by V. SI unit of Q is coulomb, SI unit of V is volt, so coulomb per volt is the SI unit of capacitance. But this is sometimes equals to farad, because farad is actually the name of the scientist who first discovered about this term electric capacitance. So therefore, in order to honor his name, in order to remember his name, we give the SI unit in his name, that is farad. Okay, now this farad is actually a very large unit. Okay, we shall see that later. So therefore, sometimes it is convenient for us to use a smaller units. Okay, and the smaller units of capacitance are millifarad, microfarad, and picofarad. And the relations of these smaller units of capacitance with the SI unit are shown here. 1 millifarad written as 1 mF equal 10 to the power minus 3 farad. 1 microfarad written as 1 mu f is equals to 10 to the power minus 6 farad. And 1 picofarad written as 1 pf is equals to 10 to the power minus 12 farad. So these are the smaller units of electric capacitance.